Hello students, in today's lecture we are going to learn mathematical methods for physics. Before we formally begin class 11th physics, it would be very helpful to first review some important topics from mathematics. Physics often uses mathematical tools to explain natural phenomena, and without a basic understanding of these tools, learning of physics become very difficult. For example, when we study motion in a physics, we frequently use concepts like differentiation to find the velocity from displacement or integration to find the displacement from velocity. Therefore, in today's session, we will revise key concept or some mathematical formulas and concepts. This will help all of us build a strong foundation and move forward in physics with greater confidence and ease. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the same. So, our first topic is fraction addition. So, fraction addition. Like fraction. Suppose we have two numbers, 1 by 8 and 5 by 8. So, how we can add both the numbers? So, look at here. In 1 by 8, denominator is 8, and in 5 by 8, denominator is also 8. So, take the LCM, you will be get 8, and then add 5 plus 1, 6. And this is applicable only for when the denominator is same. So, 6 by 8. So, it will be what? 3 by 4. When we cancel out with 2. So, 2 3 ja 6 and 2 4 ja 8. So, this will be 3 by 4. So, what is the addition of final answer? 3 by 4. Like fractions, same denominators. So, look at here. First is 3 by 5 and second is 2 by 5. Their denominator are same. 5 or 5 both are same. So, when fractions have the same denominator, we have keep the common denominator and add only the numerators. This is the procedure how we can add two numbers when numbers have in fraction. So, first keep the common denominator and add only the numerators. Then simplify if possible. So, suppose number is 3 by 5 and 2 by 5. So, according to procedure, keep the common denominator. So, here common denominator is 5. So, we have 5. Now, add only the numerators. So, that is 3 plus 2. 3 plus 2 is 5. So, 5 by 5, it will be 1. I hope this is clear. So, this is the basic mathematics, and this type of mathematics we will use in the chapter of capacitance when we add series combination and parallel combination, resistors, capacitors. So, this is very important. Unlike fraction, Like, look at here. So the denominator are different. So the fraction are unlike. So this type of problem we will solve in the chapter of capacitor. So 1 by R equivalent is equal to 1 by 3 plus 1 by 4. How we can add this? First, we take the common denominator. So here common denominator is nothing. So multiply on both sides, numerator and denominator, by a number, and that is 4. So it will be 4 divided by 12. So 1 into 4, 4, and 3 into 4, 12. Similarly, 1 into 4, 1 into 3, 3, and 4 into 3, it will be 12. So now the denominator is same. So take common, take the denominator common. So it will be 12. And now add the numerator. So that is 4 plus 3 is equal to 7 divided by 12. Now this is the value of only 1 upon R equivalent. 1 upon R equivalent is equal to 7 by 12. What will be the value of R equivalent? The value of R equivalent is 12 by 7. Reciprocal of 1 upon R equivalent is R equivalent, and that is equal to here 12 by 7. So this type of problem is very important to solving the questions related to capacitor, inductor, and resistor. I hope this is clear. Unlike fractions, different denominators. Suppose we have a two digits, two numbers, 1 by 2 and 1 by 3. So look at here, their denominators are different. How we can add? So when fractions have different denominators, we find the least common multiple. Least common multiple, or we can say LCM of the denominators. Then convert each fraction to equivalent fraction with LCM as denominator. Add the numerators. Then simplify if possible. So let's take an example. So we have a two fraction, 1 by 2 and 1 by 3. The important point here is this: the denominator are different. So take the least common, or we can say find the least common multiple. So it will be 6. So by multiplying on denominator and numerator, so here 3, 1 into 3 and 2 into 3. So it will be 3 by 6. Similarly, 1 by 3. So it will be multiply here by 2 and multiply here by 2. It will be 2 by 6. Now the denominator is same. Or another method, we can say the LCM of 2 and 3 is 6. This is the another method by taking the LCM. So here the now common, take the common 6. So it will be 6. So and then add the numerator. So it will be 3 plus 2, 5 by 6. Clear? So this is the method to add the two fractions. So I repeat it. So this is very important. Unitary method. Unitary method. So let's take an example. A car runs 150 kilometer on 15 liters of fuel. 15 liters of fuel. How many kilometers will it run on 10 liters of fuel? So there is a question in this question given that the distance is 150 kilometer and fuel is 15 liter. So question asked about the for the 10 liters how many kilometer a car runs. Direct proportions. So direct proportions or direct variation is the relation between two quantities where the ratio of the two is equal to a constant value. It is represented by proportional symbol, this one. Listen carefully. This symbol, this is the symbol of the proportional. This is the symbol of proportional, or we can say proportionality symbol. Directly proportionality symbol. It means what? It means suppose we have a V is equal to IR, Ohm's law. So here we can say V is directly proportional to I. So this is the directly proportional. Example, V is directly proportional to I, or we can say proportionality symbol. Directly means there is a no any term of fraction. So it is direct proportional. Another is inverse proportional. Inverse proportion means two quantities are related in a way that when one increases, the other decreases proportionally and vice versa. And this concept is also important. Example, f is inversely proportional to r square. There is a two method to learn it. First is f is inversely proportional to r square. Inversely means if f increases, suppose f increases, then r decreases. If f decreases, r increases. So this is the meaning of inversely proportional. Second is, if we talk about f is directly proportional to 1 by r square. 1 by r square. Here we take both complete fraction 1 by r square. Clear? So this is the directly or inversely. Directly means, look at here, v is directly proportional to I. Here f is inversely proportional to r. Inversely proportional to r square. Clear? Unitary method example. Problem. A car runs 150 km on 15 liters of fuel. How many kilometers will it run on 10 liters of fuel? Solution. First, find kilometer per liter, per 1 liter. So here 150 kilometer on 15 liters. 150 kilometer in 15 liters. So in 1 liter, how many kilometers? So in 1 liter, there is a 10 kilometer. 150 divided by 15. Clear? Then 10 liters, how many kilometers? So in 10 liters, so there is a 100 kilometer. This type of question, first of all, we find out the kilometer per liter. Then we multiplied, that will be asked. So answer, the car will run 100 kilometers on 10 liters of fuel. Clear? Direct proportion example. So example, V is directly proportional to I. Voltage is directly proportional to current. So this is the symbol of proportionality. Here V is directly proportional to I. If voltage V1 is equal to 12 volt, listen carefully. If voltage V1 is equal to 12 volt, produces current I1 is equal to 2 ampere. Then for V2 is equal to 24 volt. So the ratio V1 divided by I1 is equal to V2 divided by I2. So V1 is 12 volt and V2 is 20 volt, 24 volt, and I1 2 ampere, and I2 is what? So taking the cross product, you will be get the value of I2. So I2 is equal to 4 ampere. Multiply 12 I2 is equal to 48. So you will be get I2 is equal to 4 ampere. When voltage doubles, current also doubles. Inverse proportional example. Look at here. F is inversely proportional to R square, or we can say gravitational force is inversely proportional to square of distance. So this is important. The sign of inversely proportional is important. When we will learn gravitational chapter, where this term is present, there is a this term. Force is inversely proportional to R square. If F, or we can say force F1 is equal to 100 Newton at distance R1 is equal to 2 meter, then R2 is equal to what? R2 is equal to 4m. If we calculate for R2, that is 4m. So F1 R1 square is equal to F2 R2 square. So putting all given terms, you will get 100 into 2 square is equal to F2 into 4 square. So what will be the value of F2? So F2 is equal to 25 Newton. So to solving this type of equations, we need to understand F is inversely proportional to R square. So here main focus on the to learn about the meaning of inversely. Inversely means if one term is increased, another one decrease, and vice versa. When distance doubles, force reduced to 1/4. Suppose the distance is double. Double means 2. So 2 square, the square of 2 is 4. It means force reduces to 1/4. Clear? Scalar and vector. So scalar is a physical quantity that has only magnitude, whereas vector is a physical quantity which has magnitude and direction both. In the chapter of motion in a straight line, we will learn this very briefly. Scalar quantities have magnitude, do not have a direction. So here question arises, what is the meaning of magnitude? Magnitude means any number. Magnitude means any number. So scalar quantities has a magnitude means it has any number. Examples: mass, temperature, time, distance, speed, energy, and volume. So this is just only number or represents the magnitude. Mass 10 kg, 25 kg. Yes or no? So just number. Temperature 2 degrees Celsius, 5 degrees Celsius. Time 3 second, 2 second. Distance 4 meter, 3 meter, 2 meter. Speed 5 meter per second square. Yes or no? Energy 40 joule. Volume 30 meter cube. So they just consist only numbers. Scalar means has only magnitude. That's it. Scalars can be added, subtracted, multiplied, and divided using arithmetic operations. Clear? So we can add, subtract, multiply, divide very simply. Represented by single value, usually accompanied by a unit of measurement. Clear? scalar quantities have magnitude. So look at here, mass is equal to 50 kilograms. Symbol of kilogram is kg. Kg is the unit of the mass. This shows only the amount or size of the quantity, which is 50 kg. Just number. Yes or no? Second is do not have direction. It does not consist any direction. Temperature is equal to 25 degrees Celsius. The unit is degree Celsius. So just numbers, only magnitude. Temperature only tell us how hot or cold something. How we can calculate the temperature? By touching or using the instrument that calculate the temperature of the given body. Yes or no? So temperature only tell us how hot or cold something is without any directional component. So temperature is a scalar quantity. Example of scalar quantity. Time equal to 2 hours. Time is a pure scalar quantity that only indicates duration. That's it. It has only magnitude. That's why we call scalar quantity. And it shows only duration, 2 hours. 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So all the concepts are very important. Arithmetic operations. Adding two speeds. Suppose we have a two speeds. First speed is 30 km per hour. Speed is a scalar quantity. It has only magnitude. Second speed is 20 km per hour. Then the total speed is what? We can add both. Speed 1 plus speed 2, that is 30 km plus 20 km is equal to 50 km. Clear? Yes or no? Fifth is represented by single valued with unit. So volume is equal to 5 liters. Liter is the unit to measure the volume and symbol is L. Just one number 5 with its unit of measurement liters. These examples show how scalar quantities are straightforward measurement that only need a magnitude and unit to be fully described. Clear? Another physical quantity is vector quantity. So vector quantity consists of both direction and magnitude. Vector quantities have both magnitude and direction. Example: displacement, velocity, acceleration, force, momentum, and electric field. So about the displacement, velocity, acceleration, force, and momentum, we will learn in the chapter motion in a straight line. And about the electric field, we will learn in 12th class, chapter 1st. Electric field, a space around the charged particle in which it gives electrical effect, is called electric field. Clear? Represented by arrows. It means vector quantity represented by arrows. Suppose we have a term V and the top on the V is have an arrow. So we can say this is vector, where the length represents the magnitude. The length of the arrow represents magnitude and direction represents direction. So first vector quantity is displacement. Example: A person walks 5 meters east from their starting point. So look at here. Person walks 5 meter. The magnitude is 5. What is the direction? Direction is east. In which direction? East direction person walks. So it consists both. Magnitude is 5, direction is east. That's why we called displacement is a vector quantity. And the representation by arrow. Magnitude is 5 meters and direction east. I hope this is clear. Another vector quantity is velocity. Example, a car traveling at 60 kilometers per hour north. So representation is the vector. Magnitude is 60 kilometer per hour. The magnitude is what? 60 kilometer. And what is the direction? Direction is north, in north direction. Direction is north. So this is the vector quantity. Third is acceleration. Example, a falling object accelerating at 9.8 meters per second squared downward. So acceleration due to gravity, that is represented by small g, which is acted vertically downward. So the value of numerical value is 9.8 meter per second square. Representation by vector. The arrow. Magnitude 9.8 meter per second square. Direction always vertically downward. Clear? The direction of acceleration due to gravity is always vertically downward. Fourth is force. Example, pushing a shopping cart will 20 newtons forward. Pushing means in forward direction. And the magnitude is what? 20 and direction is forward. Representation is vector. This arrow is the representation of the vector quantity. Magnitude 20 Newton and direction is forward. I hope this is clear. This vector term is clear. It consists of both magnitude and direction. Fifth vector quantity is momentum. Momentum, the formula is mass into velocity. We know velocity is vector quantity. So momentum is also vector quantity. Yes or no? So example, a baseball moving at 30 meters per second to right. So here 30 meters per second to the right. It is a vector represented by arrow. So here magnitude is mass into velocity. So a direction is right. So here baseball moving 30 meters per second. So velocity is 30 meter per second to the right. And the mass of the ball, suppose mass of the ball is 1 kg and velocity is 30 meter per second. So this is momentum. Clear? Sixth is electric field. Electric field also has a vector quantity. Example, electric field around a positive charge pointing outward with strength 10 Newton per coulomb. This is the unit of the electric field, Newton per coulomb. Vector representation denoted by arrow. So suppose we have a positive charge. Charge is positive, this one, and the positive charge pointing outward like this, pointing outward direction. If we talk about the definition of the electric field, the space around the charged particle in which it gives electrical effect is called electric field. Magnitude is 100 Newton per Coulomb. Direction radially outward from the charge. So this one is radially outward. Yes or no? The direction is radially outward. Rate and gradient. And this is also important. When we learn chapter motion in a straight line, there is a rate and another term is gradient is present. So this is important. Rate describe the quantity that changes or occurs with respect to time. So rate describe basically position. If we talk about the velocity, so rate, suppose we have an object at point A. After some time, the position of that object will change. So the rate of change of position is velocity, shows the velocity. So rate basically describe the quantity that changes or occurs with respect to time. Another is gradient. Gradient refers to a vector quantity. Listen carefully. Gradient is a vector quantity that represents the rate of change of a physical quantity with respect to particular variable. Clear? When we learn potential, there the use of the gradient. Example, driving speed. If a car travels 120 kilometers in 2 hours, what will be the rate? So distance divided by time. So that is rate. Yes or no? Distance is 120 and time is 2 hours. We convert in 2 hours in seconds. Second is SI unit of the speed. Clear? Rate equal to 120 km divided by 2 hours is equal to 60 km per hour, or it is also represent the speed 60 km per hour. This is a rate because it shows how distance changes with respect to time. Clear? Gradient example. Temperature change on a mountain. Temperature decreases by 6.5 degrees Celsius for every 1000 meter increase in altitude. Gradient, change in temperature divided by change in height shows the gradient. So gradient is what? Minus 6.5 degrees Celsius per 1000 meter. This is a gradient because it shows how one quantity, here the quantity is temperature, changes with respect to another quantity, not necessarily involving time. So this is the best representation of the gradient, means quantity changes with respect to another quantity. So here the another quantity is height. I hope this is clear. Quadratic equations. So general form of the quadratic equations is ax square plus bx plus c, where a, b and c are the coefficients. So to find out the roots of this quadratic equation, the formula is x is equal to minus b plus minus under root b square minus 4ac divided by 2a. So this is important. This is the formula to calculate the roots value of the quadratic equations. For example, 2x square minus 5x plus 3. So, what is the value of x? We will calculate the value of x using this formula. X is equal to minus b plus minus under root b square minus 4ac divided by 2a. So this is the general form, ax square plus bx plus c equal to 0. Example, 2x square minus 5x plus 3 equal to 0. Now, what is the value of coefficient? Here, compare with general form, ax square plus bx plus c. So what will be the value of a? A is 2, b is minus 5 and c is 3. Now, using the value of a, b, c, we can calculate the value of x. So minus b plus minus under root b square minus 4ac divided by 2a. This is the quadratic formula to calculate the value of x. Or we know the value of a, b, c. So substitute here, we will get x. Using the same expression, 2x square minus 5x plus 3 equal to 0. Substituting the values in above equation. So it will be minus, the value of b is what? Minus 5. So it will be minus 5 plus minus under root value of b is minus 5. So taking minus 5 square minus 4 and value of a is 2 and value of c is 3 and divided by 2a. The value of a is 2. So putting all given terms in the quadratic formula and solving this, you will get x. So x is equal to minus minus plus, plus minus, and this minus 5 square of minus 5 is 25 and 4 into 2 8, 8 into 3 24. So it will be under root 25 minus 25 and divided by 2 into 2 is what? 2 into 2 is 4. So it will be 5 plus minus under root 1 and divided by 4. Now it will be under root of 1, it means 1. Square root of is 1. 5 plus minus 1 divided by 4. So two solutions. First is x1 is equal to 5 plus 1 divided by 4. So 5 plus 1 is 6 divided by 4. So it will be 1.5. x2 is equal to 5 minus 1 divided by 4 is equal to 4 by 4. So it will be. This example shows how to identify the coefficients and use of the quadratic formula to find the solutions. Clear? Thank you for your attention.